The final problem I'm going to cover in these complex problems is much like the other two, so that's why I'm not going to do videos for all of them. In this problem, we have a velociraptor that spots you 40 meters away. So you can see I already kind of pre-set up my picture here using the power of the internets. And it's going to accelerate the entire time at 4 meters per second squared from rest, because, you know, she's a clever girl. When it spots you, you're traveling at a constant 6 already. Apparently you saw it first. Now that's not realistic. Velociraptors would always see you first, but for the sake of this problem, we'll assume that you saw it first. How far are you going to make it before you get caught and devoured? So here we go. We're going to again draw a very careful picture here, and this is going to be the displacement of person. You'll notice that that kind of helps us to see that the displacement of the raptor will not be the same amount. But your displacement plus 40 will equal the displacement of the raptor. So I'm going to write that up here because that might come in useful a little bit later on. Displacement of person. Alright. Now we don't know much about the problem yet, so let's write down what we do know. First of all, the velociraptor is accelerating, so I'm going to write down all 5 variables for her. Well, that's dumb. And you are traveling at a constant velocity, so I'm only going to write down 3 variables for you. Now we're going to fill in what we know. The velociraptor starts from rest, so that's 0 meters per second. Accelerates, I believe, at 4 meters per second squared. And I don't know the final velocity, I don't know the time, and I don't know displacement because that's not going to be 40, it's going to be more than that, as we saw already. For you, I know that your velocity is 6 meters per second, and again, you don't know your displacement and you don't know your time. At this point in time, you'll notice that there's not enough variables in either column in order to solve this problem. So what you're going to have to do then is we're going to have to start setting up equations for this. Alright, and make sure that I know how things compare. Number 1, I already know how the displacements compare right here. Another big one to look at is time. Are they going to be different? Are they going to be the same? In this case, both you and the raptor will start at the same time, and you'll both end at the same time. The raptor because it caught you, and you because you'll no longer be alive. So I'm going to put like an equal sign here so that I know that these are in fact the same thing for both columns. Now I'm going to start writing equations. The first one will be the displacement of the person is equal to velocity times time. Or I'll put in numbers for the sake of people who like numbers. That'll be 6 meters per second times time. Now you'll notice here that I have an equation with 2 unknowns. And this is going to be another part where physics and math will intersect. If ever you have an equation with 2 unknowns, the way to solve that is to find another equation that has the same 2 unknowns. Now if you remember, I do have an equation earlier that has this. I have an equation that has that, so I have 2 equations. Unfortunately now I have 1, 2, and that's the same, but now I have 3 unknowns, which means that I'll need a 3rd equation. And that 3rd equation more than likely will come right over here. Now it gets tricky because you're like, which equation do I need to use? I have to choose 4. Well, the ones you're going to want to use are the ones in which the variables are the same. So I'm going to want to use this one, and apparently that's moving things around, and this one, and those 2. And the equation that will be is displacement is equal to, and that'll be the raptor, velocity initial times time plus 1/2 a delta t squared. That will, of course, cancel out. So now I have the displacement of the raptor is equal to, and I'll fill in these as well, 1/2 times 4 meters per second squared times delta t squared. Now that's the hardest part of this really, and well, depending on your math abilities. Because now we have these 3 equations, and displacement of raptor, displacement of person, and time. Those are our 3 variables. At this point in time, if you can set that much up, that means that you know how to do the physics, and it means that I'm going to give you a bulk of the points knowing that you can do these right here. From this point on, it's a matter of math, or system of equations. These are the 3 equations. The easiest way to solve these in this particular case is to use excuse me, substitution. So I'm going to take this one where the displacement of Raptor is equal to that, and I also have another equation where displacement of Raptor is equal to this, and I'm going to basically plug this right in for that. So wherever you see that, I'm going to write in 40 plus the displacement of the person is equal to 1, actually I'll simplify that too, is equal to 2 meters per second squared times time squared. Now I just have two unknowns. I'll have to use substitution one more time. Now I know that if I substitute in for t, then I'll be left with what I'm trying to find, the displacement of the person. So that will be the easiest for me. So I'm going to take this equation here and solve t is equal to the displacement of person divided by 6 meters per second. And that gets put in right here. So now I have 40 meters plus the displacement of person is equal to 2 meters per second squared times, and everything inside this has to be squared, the displacement of person squared divided by 36 meters squared over second squared. Alright, now at this point in time I have an equation with two unknowns. Now you'll notice within that equation though I have an x squared, an x to the first, and a term without an x. As we learned from our previous video, whenever that's the case, we have to use quadratic. Alright, I moved some things around here to make our life a little bit easier. These are the three equations that you're using again to substitute. So if you are having difficulty with the math portion of this, what I suggest that you do is I suggest that you take these three equations on their own and attempt to do the math from this point on, and forget about the physics so you can practice with that particular math. What I'm going to do now is I'm going to take my term that I have left here and simplify. So I have 40 meters plus the displacement of the person is equal to, and that will be the displacement of the person, this should be squared, I'm not sure how it became not so, all over 2 over that would be 18. And actually if I cancel my units here, I'm going to have meters on the bottom. Now I'm going to do two things at once. I'm going to multiply out 18 across the whole term, and I'm going to subtract it so that I have this equal to 0. As we discussed in previous videos, that's what you have to do in order to use quadratic equation. When I multiply out 18, that means that will cancel there, so I'll be left with the displacement of the person squared. And then I'll have a negative, because it got subtracted over, 18 meters times the displacement of the person. And then finally I'll have another negative, and that's 18 times 40. So that will give me negative 720 meters squared. I will plug it into the equation minus b plus or minus the square root of b squared minus 4ac over 2a. Once I plug everything in there, I will get two answers, and that will be 37.3 and negative 19.3. Since it's very unlikely that the Raptor would be going backwards in order to catch you, you can be pretty darn sure that the answer is actually my 37.3 meters. If you have any trouble with the quadratic equation in this particular format, I suggest that you watch the quadratic formula video that says that right there in the title. Alright, that's it.